It happens in an instant. You bend down to tie a shoelace, to pick up a fallen pen, or to lift a bag of groceries, a movement you've performed thousands of times without a thought. And then, a sudden, searing pain shoots through your lower back, a blinding flash of agony that freezes you in place. Or perhaps you've felt the dull, relentless ache of a wisdom tooth, an unwelcome visitor trying to force its way into a jaw that simply has no room to spare. In these moments of pain and frustration, a simple but profound question often surfaces: why? Why does the human body, this magnificent biological machine capable of healing its own wounds, fighting off microscopic invaders, and giving rise to conscious thought, seem so poorly designed at times? If we are a pinnacle of natural selection, the product of billions of years of refinement, why are we plagued by such fundamental, almost laughably simple structural problems? We can map the human genome and send probes to the outer reaches of the solar system, but we are brought to our knees by a slipped disc or a rogue molar. The answer, it turns out, is that these aren't flaws in the way an engineer might see a faulty circuit or a weak weld. They are not mistakes, they are echoes from the deep past. They are the awkward, sometimes clumsy, leftovers of our multi-million-year evolutionary journey. Evolution doesn't work like a master architect, drawing up a perfect blueprint from scratch for each new creation. Instead, it acts like a relentless, pragmatic tinkerer, modifying existing structures, repurposing old parts for new functions, and settling for solutions that are simply good enough to ensure survival and reproduction. This is the story of those compromises, of the anatomical trade-offs and historical baggage written directly into our DNA. It's a story etched into our very flesh and bone, and it reveals that we are not a perfect final product, but a beautiful, messy, and fascinating work in progress. To understand this process of evolutionary tinkering, we need look no further than the hidden pathways within our own bodies. Let's start with one of the most baffling and elegant examples, a nerve with a ridiculously inefficient travel itinerary. It's called the recurrent laryngeal nerve. Its job is straightforward enough: it controls several muscles in the larynx, or voice box, allowing us to speak, to swallow, and to breathe. The nerve's instructions originate in the brain, and its destination, the larynx, is just a few inches away in the neck. The most logical path would be a direct one, a straight shot from point A to point B. But that is not the path this nerve takes. Instead, the recurrent laryngeal nerve embarks on a bizarre and seemingly nonsensical detour. It travels from the brainstem down the neck, past its destination, and deep into the chest cavity. There, it loops underneath a major artery, the aorta, on the left side, the subclavian artery on the right, before finally turning around and traveling all the way back up the neck to connect to the larynx. It's a journey of several feet when it could have been one of a few inches. In an animal like the giraffe, this anatomical quirk becomes truly absurd. The nerve still follows the same ancestral route, traveling all the way down the giraffe's enormous neck, looping around an artery near its heart, and then ascending the full length of the neck again to reach its target. That's a detour of over 15 feet of nerve fiber to connect two points that are mere inches apart. Why such a preposterous design? The answer lies with our distant fish-like ancestors. In fish, there is no neck to speak of, and the structures that would eventually become our larynx and aorta are packed closely together. The nerve follows a direct and efficient path from the brain, around the 6th branchial arch artery, to the gills. It's a perfectly sensible layout. But as life crawled onto land and vertebrates evolved necks, this arrangement became a problem. The heart and its major arteries migrated down into the chest, while the larynx stayed higher up in what would become the throat. Evolution, unable to simply sever and reroute the nerve, was stuck. The nerve got hooked by the artery. As the neck elongated over eons, the nerve was forced to stretch along with it, creating the long, looping detour we see today. It's a stunning testament to the fact that evolution doesn't plan ahead. It simply modifies what already exists, even if the result is profoundly inefficient. This isn't the only dangerous compromise in our throat. Consider the simple act of eating and breathing. In most mammals, the airway and the foodway are largely separate. But in humans, they cross paths at a critical intersection in the pharynx. The tube that brings air from your nose to your lungs, the trachea, sits directly in front of the tube that carries food from your mouth to your stomach, the esophagus. A small flap of cartilage called the epiglottis works tirelessly to direct traffic, closing over the airway when you swallow. Most of the time, this system works, but every so often, it fails. A piece of food goes down the wrong pipe, and we choke. This anatomical arrangement makes choking a uniquely human hazard, a leading cause of accidental death that is virtually unknown in other primates. Why would we evolve such a perilous intersection? The answer is one of the greatest trade-offs in our history. The very thing that creates this danger, the low position of our larynx in the throatus, also what gives us our incredible capacity for speech. This lower position creates a larger pharyngeal cavity, which acts as a resonant chamber, allowing us to modulate sound and produce the vast and complex array of vowels and consonants that form the basis of human language. In essence, we traded a measure of physical safety for the power of communication, a gamble that has defined our species and allowed us to build civilizations. Our very ability to tell this story is a direct result of this beautiful and potentially fatal design flaw. Beyond the hidden wiring and dangerous crossroads within us, our bodies also harbor more conspicuous relics of our past unwelcome guests and forgotten heirlooms that often make their presence known through pain and inconvenience. Chief among these are our wisdom teeth. For millions of people, the late teens and early 20s are marked by the uncomfortable, often agonizing arrival of these third molars. They emerge at awkward angles, they become impacted against neighboring teeth, and they crowd a jaw that has no space for them, leading to infection, decay, and the need for surgical removal. These troublesome teeth are a direct consequence of our success as a species. Our early hominid ancestors had much larger, more robust jaws. This was a necessity for their diet, which consisted of tough, fibrous plant matter, roots, and uncooked meat that required a great deal of powerful chewing. Their large jaws easily accommodated all 32 teeth, including the third molars, which were essential grinding tools. But then, two revolutionary changes occurred. First, our ancestors mastered fire and developed tools. Cooking and cutting softened our food, drastically reducing the mechanical stress on our jaws. Second, our brains began to grow, ballooning in size at an unprecedented rate. This cerebral expansion reshaped the entire human skull. To make room for a bigger brain, the jaw had to shrink. Evolution, however, moves at a glacial pace. While our skulls and diets changed relatively quickly, our genetic programming for tooth development lagged behind. Our bodies are still operating on an ancient blueprint that calls for a full set of 32 teeth, but it's trying to build them inside a modern, downsized facial structure. The result is a classic case of overcrowding. Wisdom teeth are biological ghosts, remnants of a dietary past we've long since left behind, trying to find a home in a space that no longer exists. Another famous corporal resident with a questionable purpose is the appendix. For over a century, this small worm-like pouch attached to the large intestine was considered the poster child for vestigial organza, useless, evolutionary leftover. It seemed to do nothing but create problems, with appendicitis being a common and life-threatening medical emergency. The standard view was that it was a shrunken remnant of a larger cecum, an organ that in our herbivorous ancestors was crucial for digesting tough cellulose from plants. As our diet changed, the cecum shrank, leaving behind the appendix as a functionless anatomical footnote. However, modern science has begun to rehabilitate the appendix's reputation, at least partially. More recent research suggests it's not entirely useless after all. It appears to function as a safehouse for beneficial gut bacteria. Rich in lymphatic tissue, which is a key part of the immune system, the appendix may act as a reservoir, protecting a sample of our healthy gut microbiome. After a severe bout of illness like dysentery or a course of powerful antibiotics wipes out the intestinal flora, the bacteria stored in the appendix can emerge to repopulate the gut and restore balance. While this function would have been critical for our ancestors, in the modern world of sanitation and medicine, its importance has waned significantly. So while it's not the completely useless organ we once thought, the severe risk of inflammation still makes it a prime example of a structure whose benefits have been dramatically outstripped by its potential dangers, another evolutionary compromise we live with every day. Our evolutionary past isn't just recorded in our physical parts, it's also embedded in our reflexive behavior-sentient software still running on our modern biological hardware. Take, for instance, the strange and involuntary phenomenon of goosebumps. When you're cold or frightened, tiny muscles at the base of each body hair, known as erector pili muscles, contract. This causes the hair to stand on end, creating the familiar bumpy texture on your skin. It's a completely useless reflex for a modern human. Our sparse body hair provides no meaningful insulation when it stands up, nor does it make us look significantly larger or more intimidating to a potential threat. But for our much hairier mammalian ancestors, this reflex was a vital survival tool. For an animal covered in a thick coat of fur, raising the hairs creates a pocket of trapped air close to the skin, a natural layer of insulation that helps conserve body heat in the cold. In a confrontation, this same pillow erection makes the animal appear bigger and more formidable, a bluff that could be the difference between fighting and fleeing. When you see a cat's fur stand on end as it arches its back, you are witnessing this ancient mechanism in its fully functional form. For us, goosebumps are a neurological ghost, a phantom reflex from a time when we were furrier, colder, and more frequently threatened creatures. Perhaps the most significant and consequential evolutionary leftover is one we feel every single day: the immense strain placed on our skeleton by the simple act of standing upright. The transition to bipedalous walking on two legs was arguably the most pivotal moment in human evolution. It freed our hands, allowing us to carry food, care for infants, and, most importantly, create and use complex tools. This liberation of the hands paved the way for the development of technology, culture, and the giant brains that define our species. But this revolutionary shift came at a steep price. Our entire skeleton is a compromise, a structure originally designed for life on four limbs that has been hastily retrofitted for an upright posture. The full weight of our torso, head, and arms now bears down on a spine that evolved as a horizontal arch. This vertical load creates immense pressure, particularly on the shaped curve of the lower back, making chronic back pain, slip discs, and sciatica incredibly common ailments. Our feet, which evolved from grasping appendages like those of apes, have been repurposed into load-bearing platforms, leading to a host of problems like fallen arches and plantar fasciitis. Our hips and knees, now responsible for supporting our entire body weight with every step, are prone to arthritis and injury. The very posture that made us human is also the source of our most persistent aches and pains. We are, in a very real sense, still struggling to fully adapt to standing on our own 2 feet. From the nonsensical detour of a nerve in our neck to the dangerous crossroads in our throat, from the unwelcome crowding of wisdom teeth to the mysterious purpose of our appendix. From the ghostly reflex of goosebumps to the chronic ache in our backs, our bodies are a living museum of evolutionary history. They are filled with compromises, jury-rigged solutions, and anatomical remnants that tell a powerful story. These so-called flaws are not evidence of failure. On the contrary, they are some of the most compelling and elegant proofs of evolution we could ever hope to find. They demolish the notion of a perfect, intelligent designer creating life from a clean slate. Instead, they reveal the true nature of the evolutionary process, a pragmatic, unguided tinkerer, constrained by history, working only with the materials at hand. Evolution cannot go back to the drawing board. It can only modify, repurpose, and build upon what came before. The result is not a masterpiece of flawless engineering, but a mosaic of brilliant adaptations layered on top of ancient and sometimes awkward foundations. Understanding these imperfections offers us a more profound and humble appreciation for our own bodies. It transforms our aches, pains, and frustrations from mere annoyances into meaningful connections to our deep past. That twinge in your back is a direct link to the moment our ancestors first stood tall on the African savanna. That troublesome wisdom tooth is a souvenir from a time when our lineage relied on sheer jaw power to survive. These are not glitches in the system, they are the scars and souvenirs of a remarkable journey of survival, adaptation, and change that has unfolded over millions of years. So, the next time you feel a shiver send useless goosebumps across your skin, or find yourself carefully chewing to avoid choking, take a moment to reflect. What other stories from our distant past are written into your own biology? And as our environment and lifestyles continue to change, how will the unceasing, tinkering process of evolution continue to shape the human body of the future? We are not the end of the story, but merely a single, fascinating, and beautifully imperfect chapter.